3x squared is the GCF, and then we're left with 5x minus 3. And again, if you want to use the distributive property, whether mentally or physically writing it down, you will get back what you started with. For number 3, we are going to go with the highest value of 2 divisible into 20 and 22. A to the 4th and A, we go with A, and B to the 2nd and B to the 6th, we go with B to the 2nd. And again, when you factor this out, we're left with 10A cubed. And in the second term, we're left with 11B to the 4th power. And again, you can distribute. Finally, for number 4, and this is one where you might have wanted to do this. So 7A cubed B squared C cubed, 7A cubed B squared C cubed, and 7A cubed B squared C cubed. So 7 is the largest that goes into 21, 7, and 35. A to the 5, A to the 3, and A to the 5 again. We're going to go with A to the 3, B to the 2, B to the 5, and B to the 2. We go with B to the 2. And C to the 3rd would be the smallest in all the C's. When you factor out, you're left with a 3A squared, the B squareds and the C cubes cancel. In the second term, the 7s cancel. And when I say cancel, I mean reduce to 1s. We're left with the A cubed canceling, B to the 3rd power, and C to the 1st power. And in the last one, 35 and 7, we're left with 5A. That is a 2 there. I'm sorry if it looks a little, oh no, you can see the 2. 5A to the 2, B squareds cancel, and C to the 5th power. So before we go to the next section, any questions on 1 through 4? Great. I'm also going to post this like I always do, either tonight or in the morning. So again, just be on the lookout. The next 3 problems were just to factor out a negative GCF. So recall from our conversation on Monday that if a polynomial starts with a negative, we will factor out the negative. -5, and by the way, when we factor out a negative from something, it negates. We really want to use that word negates. So negate means that it's going to change or go opposite the sign. So -5 gives us a y plus 6 in the parentheses. Again, distributive property can verify that. -2, and then everything will of course negate. So x squared minus 3x plus 5. And then -16 comes out. Sorry, my students are emailing me. And we are getting y squared plus 2y minus 5. So again, just maybe make a note that if a polynomial starts with a negative, we tend to want to factor out that negative. Okay. Please let me know if anyone needs me. Now we're going to go to our next part in a moment. Okay. So now these are special binomials. They're either going, so if you see a binomial, guys, binomials are 2 terms. So if you see a binomial and there is a minus in between, you're first going to ask yourself, are they perfect squares? If they are not, and you have a minus or a plus in between, then they may be cubes. So n to the 2nd and n squared minus 36, I'll write the square roots down. So n minus 6 and n plus 6. By the way, every one of mine have a minus first. That's just coincidental. The terms order do not matter. 121p to the 2 and 4. So we get 11p and then 2. And again, there are your factors. 169m to the 2nd and 4n to the 2nd. So there are your terms or the roots. And finally, 25t squared gives us 5t and then 8 over 11. The last difference of squares is number 5. So we get 7 over 9. And this is 10a. And those would be our roots as well. Okay, so those are your difference of squares. The second type or the last 3 are all cubes. So m cubed plus 8. Remember that we take the cube root. So the cube root is m and the cube root is 2. I'll go over these for you guys. So we have a binomial and a trinomial that form. Because, let me get a different color to show you. Because we start with a plus, we go plus, then we go opposite, and we always end in plus. The 2 terms cube roots go in the front, so m plus 2. This is what's in the binomial squared. This is their product. And this is the second term in the binomial squared. And then you're done. You don't have to factor that anymore. 27, same deal. So this is 3p and this is 1. start with a minus. So we go minus, then we go plus, and then we always end in plus. The binomial gets the 3p and the 1. So this is 3p squared. This is their product. So 3p times 1. And then this is 1 squared. Oops, sorry. And finally, for the last one, so this is going to be 4a to the second. Remember that a to the sixth, when divided by 2, would give me divided by 3 would give me a squared. And this is 5. So 4a squared and 5. And then you can see I did 4a squared. That's 4a squared squared. So we have to square the coefficient and the exponent. Same with the 5. And then, of course, their product goes in the middle. So make any corrections that you guys need, and then let me know if there are any questions. And then we're going to go to our second page. So far, I think this is going relatively smoothly. I'm hoping you guys are building that confidence in your recognition as well. Okay, so I'm just going to pause for a moment to let you guys catch up. Okay, and now let's go down to factor by grouping. So we use grouping when we have 4-term polynomials. We also use it for trinomials. So remember, you always want to have a plus between the groupings. In the first set of groupings, you have a 3a squared, and we're left with a plus 5. Then we factor out a positive 2, and we're left with a plus 5. You want these binomials to match. Comes out in front, we're left with 3a squared plus 2. For number 2, however, you have that minus attached to the negative 12. So we throw that plus in between. And then, of course, we go and we put our minus 12 inside the parentheses. So 7n squared comes out. We're left with 3n minus 2. And then negative 4 comes out and negates our terms. We're left with 3n minus 2. 7n squared minus 4 and 3n minus 2. And please just make sure that your binomials are completely factored. Let me do the first 4 of these, and then I'll pause for questions on anything I said on this page. So when your a value has a coefficient of 1, we know this will factor into 2 binomials. A and a go in front to give us back a squared. We're looking for factors of 16 that add to negative 10. So, and factors mean they multiply. 2 and 8 were the lucky numbers, and they're both negative to multiply to a positive, but to add to a negative 10. Number 2, same deal. So you have a 1 in front of the q squared. That means that you're going to have q and q. 38, so we're looking for factors of 38 that give us 21, 1 and 38. And then 2 and 19 were the lucky numbers. Since everything is positive, your factors are positive. When you have an a value that is more than 1 for the rest of the problems, you're going to use the a times c method, so negative 20. And then we're going to look for factors of negative 20 that add to negative 1. That's your coefficient on the middle term or the b term. 1 and 20 will never get me to negative 1. 2 and 10 can never get me to negative 1. But 4 and 5 can. If 4 is positive and 5 is negative, they multiply to negative 20, but they add to negative 1. I mentioned the other night that the order of your terms does not matter when you expand the middle term, but I like to place things that kind of jive together. So the 5y goes nicely with the 5y squared, and it's negative. The 4y goes nicely with the 4, and there is your final answer. Okay, let me do 4, and then I'll pause for questions, and then we'll continue. So for number 4, you guys have a times c is 28. We're looking for factors of 28 that add to 11. That's positive 4 and positive 7. So the middle term will expand using 4m and 7m. I like the 7 to go with the 14m squared. Those go nicely. And the 4m to go with the 2. And we would be left with 7m plus 2 and 2m plus 1. So I'll give you guys a minute if you need any time to make any corrections. You know, I, of course, will post this for you. Or if anyone has any questions regarding any of the problems so far. Okay, so I'll give it like 30 seconds. And then we are going to finish with our last piece. So I'll just kind of slide it up. Okay, for number 5, we're going to do 4 times 5, which is 20. So factors of 20 that give me negative 12. 1 and 20 can never combine to give us a 12, but 2 and can too. If they're both negative, they multiply to positive 20 and they add to negative 12. I like the 2t to go with the 4t squared. I think those jive nicely. And by the way, you're using negative 2t and negative 10t, so that's a nice thing to write down. I like the negative 10t to go with the 5 because those goes nicely. Again, notice the plus in between the groupings. Factoring out your GCF, you reveal those same binomial factors. And so 2t minus 1 and 2t minus 5. And as I mentioned on Monday, if you guys want to check this, all you need to do is use distribution or FOIL and ensure that your answers are correct. Finally, number 6, and then we have 2 more. So 6 is 5 times negative 4, which is negative 20. I just have to move you guys this way so I can see it. Factors of negative 20 that add to positive 19. So, but guys, I also wanted to mention, some people were having a little bit of an issue. So I'm going to talk about the signs, but let me finish this first so I don't lose my train of thought. So 20 and negative 1 would add to 19, but they also multiply to a negative 20. So you're going to use a negative 1x and a positive 20x to expand. I like the 20x to go with the 5 because they go nicely together. And then I like the negative 1 to go with the negative 4. So when you have a negative 1x minus 4, to make it match that x plus 4, we would factor out a negative 1. And of course, that also goes with if a polynomial starts with a negative, we factor out the negative. I wanted to mention about the sign. So when you do a times c, okay, if it's a negative, then the terms have to be plus minus or minus plus, depending on how you assign them. If you have a times c as a positive, then you're going to have either 2 negative terms or 2 positive terms. So I don't know if that helps. Some people were telling me they were struggling on Monday with the signs. So that might be something that you might want to consider. For number 7, we're going to do a times c to be 60. Factors, so look at what I mean. So a times c is positive, but since the middle term is negative, they both have to be negative. So that's another way you can memorize it. 1 and 60 can never get me to 23. 2 and 30 can never, but 3 and 20 can. If 3 is negative and 20 is negative, they will multiply to 60, but add to negative 23. And again, you can put the 20p with the 4p squared. I think those go nicely together. And the negative 20 with the 15. And again, it doesn't matter if you don't use that order, you will get the same thing. I also said before that if you guys are still wanting more practice, this entire unit is more factoring. So we're going to factor tonight, we're going to factor Monday, we're going to factor next Wednesday. So you're going to get exposed to quite a bit of factoring in here. Finally, for number 8, and then we'll go to our last 6 problems. 2 times 1 is going to give me 2. Factors of 2 that add to 3 are simply 1 and 2. So you can use a 1x and a 2x. I like the 2x to go with the 2x squared and the 1x to go with the 1. Just note here that you do have to factor out something. So if the binomials do match, then a 1 just comes out so that you at least get those 2 binomial factors. So questions on any of those before we finish the last 6, please? Okay, that's a good sign. And then we have factor completely. And just to review what I discussed the other night, you guys are going to look for a GCF first, okay? Then you would check for a difference of squares, so it has to be a binomial. If you don't have a difference of squares, you might have a difference or a sum of cubes. Okay, so let me kind of like separate these. And then finally, a trinomial. So I'll write down what happened in each example for you guys. So in number 1, we had a GCF of 9, and then we had a difference of squares. So 9 gives me b squared minus 1, 9 times b plus 1 times b minus 1. Now you guys know your exam will be multiple choice, but one of the biggest mistakes that people make is they forget to include the original GCF that was factored out. So please be careful. If you weren't here on Monday or you you downloaded the homework early. Number 2 was supposed to have a 3 in front of the n to the 4th. So if you missed that, don't worry about it. I'm not going to get on anyone. You can fix it now, however. So there was a GCF first of 3n to the 2nd power. And then that revealed n squared minus 9, which was again a difference of squares. So hopefully that helps you guys see the order. For number 3, there was a GCF of 6, and then it was a trinomial because it's not a binomial, it's 3 terms where a was equal to 1. So we were simply looking for factors of 6 that added to 5. And again, the terms order doesn't matter. However, any monomial GCF goes out in front. For number 4, there was a GCF of 7. That was the first thing that we could have identified. And then it was a trinomial, but it wasn't a trinomial where a was 1. It was greater than 1. So the A times C method. So we're looking for factors of negative 24 that add to, factors of negative 24, yes, that add to 2. And the magic numbers were 4 and 6, with 6 being positive and 4 being negative. The 4y went with the 8y squared nicely, the 6y with the 3. Factoring out the GCF, we reveal the same binomials, and there are your terms. And again, this is what I was talking about. So please do not forget to put the GCF out in front. Okay, last 4. So there was a GCF of 4mn in this first problem. And then it was a trinomial where a was equal to 1. So we would look for 2 factors, of negative 10 that add to negative 3, and that's negative 5 and positive 2. Number 6 had a GCF, so a lot of GCF, as you can see, of 8v to the 5th. That revealed a trinomial where a was equal to 1. And that means that we would look for factors of 6 that add to negative 5, which were negative 2 and negative 3. Number 7 was similar to a question we did the other night. So instead of x to the 2nd, we have x to the 4th, but a was equal to 1. So it would factor into x squared plus 5 and x squared plus 5, factors of 25 that add to 10 or 5 and 5. And lastly, we had a difference of squares. Okay, so firstly, that was 4x squared plus and 4x squared minus 9. But then in here, right here, there was another difference of squares, giving me 2x minus 3 and 2x plus 3. This is a sum of squares. Sums of squares, as I mentioned on Monday, cannot be factored. Okay, so that is the homework in its entirety. I hope that this was okay for you guys. Again, I hope it was minor corrections. What I'll say is I can answer anything fast, but if anyone does have something major about this or prefers to wait, stay on after and I can spend some time, because I don't really think we're going to go very late this evening. So there it is. So we're going to start with lesson 7 tonight. If you guys can have that ready, I'm going to share the screen with that in a moment. I'm going to leave a lot of the work more to you guys tonight to really get the practice. But of course, I will model how this all works so that you guys are okay. I think you guys will like this. And I think that if you are feeling a little more comfortable with the factoring, this is going to be a piece of cake. So I'm hoping that you guys will feel that way. So again, I'll post that for you. Here is lesson 7, and it is called reducing rationals. So a rational expression is an expression in which we have a basically a fraction, and we're going to have a polynomial in the fraction. I wrote there that Q cannot equal 0. When you guys go on to a higher level math class, if you're taking, let's say, college algebra, you would revisit this and you talk about the denominator not being allowed to be 0. Some of you guys might recall hearing about that from way back when as being undefined. That is not anything you guys have to worry about in this class, but it is something that will come up later if you take that class. Now, the rules are very simple. You're simply going to factor everything and then cancel like factors. Now, there are some ground rules about what we want to be careful about. So if you have something like A plus C and B plus C, we don't just cross out the C's. It has to be the entire binomials must be the same. This symbol right here is called the not equal to. So it's saying that this does not become A over B. Same is true in the second example on the right. You cannot just cross out the C's. And the third example on the bottom. Now, what you can do is if you have A plus B over A plus B, since those are exactly the same, it would reduce to a 1. Sorry, the whole A plus B. If you have A minus B over A minus B, that would also reduce to a 1. And then this is a very important one that I'd like you guys to put in your notes because you're going to need this in a little while. If you have A minus B over B minus A, so if they are interchanged, meaning just the terms are opposite, but there's a minus in between, these will actually cancel to a -1. That is a special case, and I will bring it up. There's going to be several times where it does come up this evening. So I'm going to model 4 problems. Actually, I'm going to model, yes, 4 problems for you. We're going to start with just monomials. Now, you guys should remember that when we are reducing a monomial, we actually go and we we subtract the exponents. But I'm going to now pose this a little bit differently for you guys. So here we go. I'm going to do these 4, then I have 4 for you to try right after. So I'm going to start with the 4 and the 16, which easily reduce to 1 over 4. Reducing fractions with numbers should be easy. Now, guys, instead of doing 7 minus 9 and writing -2, think about it logically. If you have x to the 7th on top and x to the 9 in the bottom, the fact that the 7 on top is smaller than the 9 in the bottom, you know that you're just going to be left with an x squared on the bottom. If that is too much for you and you really do need to write it out, then you can write it out by subtracting, but then remember no negative exponents, so it will go in the bottom, okay? And then we have y to the 12th and y to the 4th, and because the 12 is larger than the 4, we are going to just keep y to the 8th on top. So we have 1y to the 8th or y to the 8th over 4x squared. And I'm just going to box that in. Okay, we're going to continue. And I'm going to do the next 3. And then, like I said, you will have time. So 6 and 21 reduced by 3. I'm just going to make a little note. To 2 over 7. So here it is again, a to the 2 and a to the 7. The 2 is smaller, so it would be a to the 5. But again, if you need to do this, go for it. And then b to the 3 minus 10 would give me b to the -7. So that would go in the bottom as positive. So basically, if the exponent is larger on top, it will go on the top. And if it is larger on the bottom, it will go in the bottom. Letter B, I kind of went out of order, no big deal. So 14 is going to be 2 and 3. I have a to the 5 minus 2, which is a to the 3. I have b to the 4 minus 6, which is b to the -2. So you guys basically have done all this. And I have c to the 7 minus 2, which is c to the 5. And finally, for D, we have a negative over a negative, which becomes a positive. Sorry. 42 and 22 are going to reduce by 2, but by -2. So we'll have 21 and 11. The m to the 3s are the same, so they cancel. Now they do reduce to a 1, but I would just put, you don't have to write the 1s. N to the 16 on top and n to the 20 on the bottom. That's n to the 4. And then there is no other p, so that is p squared. So that is 11n to the 4th on the bottom. I know it's kind of hard to see the 4. Okay, any questions before you guys try? Okay, so the next slide is for you. Same deal, 4 questions. I am going to give you guys, I don't think you need more than 5 to 6 minutes. So I'm going to start my timer on the phone. If any of you guys do need me, please feel free to ask questions. but I'll get you guys started right there. So I put the timer on. I will give you minute updates. I'm just looking at my notes on my phone. Sorry, I did not mean to do that. Okay, and if you want to write in your notes, again, these are called monomial rational expressions. Okay, so you have a minute down. Okay, you got about 2 minutes down. Okay, you guys have about 2 minutes left.
I had a question on A.
Absolutely, go for it. Your A or my A?
A 10, the one that the
Yep.
10.
Okay, the one you guys are working on.
Yeah.
Go for
Can
it.
okay.
You can ask,
Do
yeah.
you divide the 10 divided by 2 and then the 16? Okay.
That is called your GCF, just like when you have it in a, in a line. So it's just
Mhm.
simply reducing fractions. So you're right. And of course, because it's a positive over a negative, it will just stay negative.
Okay.
Yep, you're perfect.
And everything goes on the top.
If it's
You flip.
if it's a situation where your exponents are positive. So basically, again, just to reiterate, if your exponents on top are larger than on the bottom, then they'll all go on the top.
Okay, got it.
Okay, cool. All right, we have just about a minute left for you guys to try these. Okay, so you can finish that up. Okay, about 30 seconds. Okay, so we're going to get started. So as mentioned a moment ago, we are going to divide the top and the bottom. You get a little darker color going here. we're gonna divide the top and bottom by 2. So 5 and -8. 8 to the 2, 5 minus 1 is 8 to the 4 on top, and b to the 2. And I understand there's not really much work for these, so it's totally okay. For C, we have 22 and 12. So that will have 2 in common, 11 on top and 6 on the bottom. So m to the 10th on the bottom, and n, not m, but n to the 6th on the bottom as well. And that's because m to the 2 minus 12 is m to the -10, n to the 1 minus 7 is n to the -6. For letter B, I keep going out of order. So 9 is going to be the largest value that goes into both the top and the bottom. Okay, you're going to get 2 over 5. X to the 2 from x to the 5 will be x to the 3. Y to the 7 in the bottom, and the z squareds cancel. And again, if you need to see it, here it is. So this is going to be equals x to the 3. And then y to the 4 minus 11 is y to the -7. And finally, we are going to have our last one, which is going to be divisible by 8. If you started with 4, you would have had 10 over 22. And then you would have to reduce that again. So it's important to try to get the largest one, or at least reduce as much as possible. So I'll make a little note here that 8 was the better value. So 5 and 11, 8 to the 1 on the bottom, the b to the 3's cancel, c to the 3 on the bottom. And again, if you need to see it, this is a -1, hence the bottom, b cubes cancel, and then -3 in the bottom. Okay, so any questions on the monomials before we go to our next piece? Okay, Aaliyah, question?
Actually, yeah. So
Sure.
I thought, for A, the first one, -16, do you only change it to the top when the exponent is negative? Because I kind of flipped it
No,
around.
yeah. So it's not, okay, I see what you did. You put the numbers?
Yeah, I flipped the
No,
numbers.
Those don't get changed. So remember that the negative doesn't affect the numbers. It's the exponent. Okay,
Okay.
so, right. So that's a good question actually to ask. So when you are dividing those exponents and you're subtracting them, if you get a negative, like in situations B, C, and D, then you would put them in the opposite part of the fraction. But the coefficients just reduce as is.
Got you. Thank you.
You're very welcome. Anyone else with any questions for me? Okay, so we're gonna do same thing. I'm gonna.
I have a question.
Sure,
I'm
go ahead,
sorry.
Marianne. No, don't apologize, guys. This is why I wait till we could do it. Go for it.
So letter C, I'm a little bit confused. So
Sure.
you divided the greatest common factor for 22 is 11, but then for 12M.
No, it's not 11, it's 2. It becomes 11 because the largest value is 2.
Okay,
Does that help?
yes,
Okay, just like in B.
sorry.
No, don't
Okay.
listen. This is why we're here to ask. Don't ever apologize. Just like with 45, you're dividing by 9. Whatever you do to the top, you must do to the bottom.
Do
So
to
you're
the
not gonna,
bottom.
exactly. You cannot divide something by one value and then divide something else by a different, because
That's what I figured.
then
Because
it's
I was
not
gonna
really-
ask you, how did you divide it by
Yep.
2 different numbers?
Right.
Okay,
So it's the same deal like when I was just saying before, like when we were doing the factoring and you are dividing out a GCF, it has to be the common value to every term, whether you have 2 terms, 3 terms, whatever the heck amount.
okay, thank
Yep.
you.
You're very welcome. Okay, so as I was saying, guys, I am going to kind of get you guys started. I have quite a few examples. So what I'm going to do is I may just start to do them, and then I may just say, all right, you guys take over. So let me show you what happens when we do not have monomials anymore. And this is the big, you're going to be doing a lot of this, especially next week. So if you remember a little while ago, we have to factor everything first before we reduce. In the monomial situation, it's a little different, but now when you have multiple terms. So for instance, I'm going to factor E, which is 4x minus 8 first. So remember my factoring rules. I'm going to check for a GCF. There is one. 4, and I'm left with x minus 2. And then in the denominator, I'm going to factor out 5 because that's the common value for the denominator. So guys, when you're factoring, you're looking at the numerator first on its own. You're looking at the denominator on its own. So you're not looking at GCF between the top and the bottom like I just mentioned. That's when you have single numbers. You are factoring each top and bottom separately. So now we're left with 5 times x minus 2. Now, if I can't factor any further, I then ask myself, is there something in common? Do I have a common value? Well, 4 and 5 are not going to have anything in common, but x minus 2 and x minus 2 do. And because they are the same, they reduce. Now, remember, they reduce to ones. I normally don't write the ones. And so the final answer is 4 over 5. Okay, so just to reiterate, you are going to factor the top completely separately, the bottom completely separately, and then if there are any like factors, you're going to cancel. Let me show you one more, and then I'll see if anyone needs me before we continue. This is not allowed. Please don't ever do this. Don't ever do this. No, no, no. So that's what I was talking about earlier. Big no, no. What you're going to do instead is you're going to factor. So in the numerator, I have a GCF of 3. In the denominator, I have a GCF of 3. Now, the a minus 6 and the a plus 6 do look very similar, but they're not. So because they are not the same, sorry, they're going to stay as is. The 3's, however, are the same, so we can reduce or cancel those, and we're left with a minus 6 over a plus 6. And it takes some getting used to, but it is not anything you guys can't handle. Let me actually do G and then I'll take questions just so you guys can see one more. So in the numerator, I do not have a GCF, but the second thing I look for is the difference of squares, and I have x squared minus 16. So that factors into x plus 4 and x minus 4. And then in my denominator, I have a trinomial. Now remember, 16, the a value is 1. So I'm looking for 2 binomials, x and x. 2 factors of 16 that add to -8 are -4 and -4. Now, it does not matter which one you cancel with which, but you are going to be left with one of the x minus 4's in the bottom. So let me just let you guys catch up here, and then I'll reduce it, and we'll go from there. Okay, so the x minus 4 will cancel with the x minus 4. I just like to go with the first ones I see so I can keep track. These are not the same, even though they look the same. And so that is our answer. So any questions? Okay, why don't you guys try H without me now? So I'm going to give you guys a little time. Why don't you guys try H and see how H goes? So I'll give you a few moments to work through H. Okay, so I'll give you, let's see, I don't have my watch on. I don't know, another minute. And again, what you guys see now, you will be seeing a lot of, especially next week. Sorry, I keep hitting this thing. Those of you that are came in a little later, next week, you guys are going to have 2 more lessons. The homework is due on Wednesday, and our next exam is 2 weeks from this evening. Okay, so let's see how you guys did. So the numerator does not have a GCF. It is a trinomial with the a value being 1. So there are my 2 binomials. Factors of 4 that add to 4 are 2 and 2. In the denominator, we have a GCF of 6. When we factor that out, we're left with x plus 2. X plus 2 cancels with an x plus 2. And we're left with x plus 2 over 6. You can drop the parentheses if it's one binomial left. Okay, so any questions before we move forward? Okay, so now I'm going to leave it to you guys where I'm going to show you one and then I'm going to make you try. We're going to kind of go that direction tonight. So I'm gonna just scroll to this page. So I will do I, and then I will let you guys do J. First thing we check for is a GCF only, always. There is a GCF of 7, revealing x squared minus 9. Now that can still be factored. So what I'm going to do is I'm going to factor that here as x plus 3 and x minus 3. It is a difference of squares. In the denominator, I have a GCF of 2x, and that would give me x minus 3 left over, which I will just rewrite here. The 7 and the 2x are monomials, but they will not reduce. The x plus 3 on top doesn't have one on the bottom, but the x minus 3's cancel, and so we're left with 7 times x plus 3 over 2x. Now, people always ask me, do I need to distribute the 7 or can I leave it alone? My answer is leave it. Know that you could distribute, but it is not necessary. So I'm open for questions. If not, I'm going to set a timer for about 2 minutes for J, maybe 3. Okay, but please feel free to ask if you need me. So you guys are trying J now without me. Okay. Now these you obviously have to show work for. Okay, you got about another minute, a little over a minute. Just try to keep it moving somewhat nicely. Okay, so in the numerator, you have a 2x as your GCF. You're left with x minus 4. In the denominator, you have a 3x as your GCF. You're left with x squared minus 16. Now you still have a denominator that can be factored more. So what I like to do is rewrite the numerator. The denominator is a difference of squares, so x minus 4, and then x plus 4. The 2 and the 3 will not reduce. However, the x's can. Because they are single x's, the x's can reduce or cancel the x minus 4's. So we're left with 2 over 3 times x plus 4 in our denominator. Okay, and I'll take any questions. I'm going to do K and then let you guys try L without me. The reason why I have asterisks next to K is because we are going to see that A minus B over B minus A scenario come up. So the numerator cannot be factored. It is 3x minus 1. The denominator has a GCF of 3, and we're left with 1 minus 3x. So as you guys can see, this is A minus B. This is B minus A. Now that will reduce to a -1, and I get this question every single time I teach this class. Does it matter where you put the -1? The answer is no, but I will make a suggestion. I'm going to strongly suggest that you put it in the numerator because it just makes it easy to keep track of, but you can put it anywhere you'd like. These will reduce to a -1. So my final answer is -1 over 3. You could have wrote 1 over -3, but I like to, this is just, I'm a creature of habit. Okay, you guys are going to do the next one. I'll give you guys some time, so I'll reset my timer. This really shouldn't take too long, so maybe just 2 to 2.5 minutes. And of course, as you guys are working, you know I always like to take questions if anyone has. So I hope that this is a nice
Have-
method. Sure, Marianne, go ahead.
For letter J, under the 2x, does it matter if I wrote 3x squared on the outside, then parentheses
Well-
x minus 16?
Well, no, because it does matter because
Oh,
3x
it does.
3x
Okay.
squared is not the GCF. You would
Oh,
have to have had a squared here for it to have been 3x squared.
oh.
Does that make sense?
Okay, yes. I
Yeah, because you got to go with that.
remember that rule.
Yeah, make sure you go with that lower exponent. Very important. So it would have definitely changed your answer dramatically.
Got it. Thank you.
You're welcome. Okay, you guys are about a minute down. This was not to trick you, by the way, the next question, so don't force things. My advice is don't force things to happen. Okay, I'll leave you with that. So you would factor out a 7 and you're left with y squared minus 3 and then 3 minus y. Now, I did this on purpose. So even though this looks like a minus b over b minus a, it is not because y squared and y are not the same. So you cannot factor this anymore. Nothing will reduce. And so you're done. So just to be fair, I'll add another one in there, but please be careful about that. So let me add one more so you guys can try. So I don't know, make this the next one right here. So let's do 8x to the second minus, let's do 8x to the second. Let's do minus 32. That should work. Over 4 minus x. No, 2 minus x. Yeah, that should be better. So why don't you guys try that one and then we'll go to our next page. Night's going fast, already 9 o'clock. Okay, so again, check for that. GCF is so powerful. Gotta write something down. Okay, take another moment. Okay, so 8 is the GCF, giving me x squared minus 16. No, excuse me, x squared minus 4 over 2 minus x. That x squared minus 4 can be factored more into x minus 2 and x plus 2. It is a difference of squares over 2 minus x. There is your a minus b over b minus a right here. So there's a minus b, b minus a. So remember that reduces to a -1. And I'm just going to put that in the numerator. So -1 times the monomial 8 will give me -8 times x plus 2. And the denominator would just become 1. So we'll leave it as -8 times x plus 2. Okay, so I'll take any questions there if you guys have. I really like the way this is going tonight. Okay, so we're now up to M and N. So I would say, why don't you guys try M without me? I'm just going to kind of keep throwing them at you just for you to practice. And then maybe I'll do N. And then we have about 5, 6, 7, 8 more problems after that. And that is really it for tonight. So, oops, soaking rain tomorrow. Okay, so I'm just watching the time. Okay, so for the number, the one that's M, we're going to go and we're going to factor out our GCF of 10. Excuse me, 10x, we're left with x plus 1. The denominator, we're going to factor out 5x, and we're left with 2x plus 3. Okay, so that GCF first. So since the 10 and the 5 are monomials, they can reduce to 2 over 1. The x's will also cancel, but then the x plus 1 and the 2x minus 3 or plus 3 are not the same. So we will just simply be left with 2 times x plus 1 on top and 2x plus 3 times 1, which is just 2x plus 3 on the bottom. Okay, so I'll take any questions on that one. I'm going to actually do n for you guys just to show how n works. Okay, so for n, we are going to factor the numerator first. There is a GCF of 2x squared. 4, 10, and 24 have 2 in common. X squared is the lower exponent. So we're left with 2x squared minus 5x minus 12. And in the denominator, we'll factor in a minute, but we can still factor the numerator, but let me do the denominator as well. So 12 and 18 have 6x to the 4th in common, and then we're left with 2x plus 3. Oops, sorry. Now, this is a trinomial that can still be factored. So what I'm going to do is I'm going to work that through over here. So 2x squared minus 5x minus 12. We are going to do a times c, which is negative 24. So we're looking for a pair of factors that goes into 24, but we'll add to 5. That would be 3 and 8. In order for that 5 to be negative, the 8 has to be negative and the 3 would be positive. So we will expand our middle term using 3x and negative 8x. I think that the negative 8x goes nicely with the 2x squared, and the positive 3x goes nicely with the 12. We factor out our GCF. And our factors are 2x plus 3 and x minus 4. And I'm going to pause to let you guys finish that or write down what you need, but I'm just going to throw them back in the problem first. And then I will take questions and give you time to catch up before we reduce this. So as you can see, the intensity of these questions is indeed getting a little bit more involved, but it's nothing you guys can't handle. Okay, so I'm just going to give you guys a little bit of time to catch up here. And then I will finish this. And then I'm going to let you guys sort of work on the next bunch without me. Okay, so the 2 and the 6 are monomials. They can reduce to 1/3. Okay, reducing fractions. The x squared and the x to the 4th will reduce to an x to the 4th on the bottom. I'm sorry, an x squared on the bottom. The 2x plus 3s will reduce. And in the numerator, we are left with x minus 4 over 3 times x squared. This x to the 2nd and this x to the 4th, again, reduced to an x squared on the bottom. Okay, so I will take questions, but for anyone who is ready, I'd like you guys to try A, B, and C. I am going to put 5 minutes on the clock for those 3 problems. I don't think you need 5 minutes, but I'll put it anyway. But if anyone does want to ask anything at this point, please feel free to do so. I'm just looking at my notes. And then we will just finish up the night by doing it like this, a couple of questions at a time. Okay, so I'm just going to move it up to right there. Okay, about a minute down. Okay, you have about 2 minutes down, so 3 to go. If any of you feel adventurous and you want to continue past those, by all means, go for it. Okay, we're gonna start soon. Okay, you're about a little over 3 minutes in. Again, don't hesitate to go forward if you're ready. Okay, I think we can get going on these first 3 at least, so let's do those. So there's a GCF of 15 in the numerator, leaving you with x plus 2. In the denominator, there's a GCF of 2, leaving you with x plus 2. Those reduce. 15 over 2 should have been your answer. For letter B, we are going to factor out our 8. So 8, we're left with y minus 3. 6, we're left with y minus 3. The y minus 3's cancel, and the 8 over 6 does reduce to 4 over 3. And we always want to reduce as much as possible. Finally, for C, there is a GCF of 2 in the numerator, leaving us with 7 minus 5x. And in the denominator, 5x minus 7. There is that a minus b over b minus a scenario. So we will, b minus a scenario. So we will reduce to a -1. Again, you know, I said it's always nice to put that in the numerator. And 2 times -1 is -2. Okay, so I'm going to give you guys some time on 3 and 4, D and E, I should say. I'll put about 3 to 4 minutes on the clock. If anyone has any questions regarding the others, please feel free to let me know.
I have a question.
Sure, go ahead.
So with the A and B, that's the variables, right? Is it like, so does it become like, I'm a little confused with the A minus B equals -1.
Oh, you mean in letter C?
No, C.
Yeah, in letters, example C.
Yes.
Yeah, okay, so It's merely if you have terms that
Mhm.
are the same, but they're flip-flopped with a minus between them.
Okay,
So anything that looks like that, 7, what was it? 7 minus 5x. Sorry, I used the wrong numbers.
Mhm.
5x minus 7. Okay, let me give
Right.
you a couple more scenarios and then I can answer a little more. So like 4 minus a over a minus 4. You seen the
Right.
pattern? Y squared minus 1 over 1 minus y squared. These
Oh,
all, go ahead.
so basically it just becomes -1. Like when it's like that, it becomes
Yes,
negative
ma'am.
one.
And that's
Okay.
because they are, so I can give you the math behind it if you really want to know. I mean, I'm sure that's like the most exciting thing on a Wednesday. But if you look at like this one, so they almost match each other. They're not
Mhm.
the same, but they're very, very close. So in order
Right.
for me to make the top look like the bottom, I
Mhm.
can factor out a -1. The 7 becomes negative and the 5x becomes positive. And now they're the exact same thing if I rewrite the order. See how it's 5x
Right.
minus 7? And since now I factored out a -1, that was what it reduces to. But you don't have to do all that work. You just have to recognize that it's a minus b and b minus a, that it's the same terms flip-flopped.
Okay,
Does
thank
that
you.
help? You're welcome. Yeah.
Yeah,
And
it does.
I use a minus b and b minus a as just generic variables to
Right.
represent that situation.
Right.
Mhm.
Thank you.
You're very welcome. Okay, we are about 2.5 in, so you should be on E at this point. Again, feel free that if you want to go to the next slide, you may. I'm not going to get upset if anyone feels like going ahead of me. So don't. Okay, so a lot of factoring, like I said. Okay, so let me just check on D for now. So there's a GCF and D of 8y in the top. And we're left with 3y minus 4 in the bottom. And then in the bottom, there is a GCF of 16y, leaving me with 2y minus 1 in the bottom. The 8 and the 16 are monomials, so they will reduce to 1 over 2. The y's can cancel, but then those binomials will stay. So in the top, we're left with 3y minus 4. And in the bottom, we're left with 2 times 2y minus 1. Okay, so just you're canceling either like monomials or like binomials. And of course, the special situation. I'll give you guys a little bit more time on E, but of course, if anyone feels like going ahead to F, G, and H, go for it. So again, I really want to reiterate the power of the GCF, how important it is to factor that out. Okay, so for E, we're going to factor out our GCF in the top, 2x squared y to the third. Remember, we go with the lower exponents. So we're going to be left with x minus y. 2 from 2, x squared from x cubed is an x. Y cubes cancel, and then the 2's go, the x squareds go, we're left with a y. Denominator, we have a GCF of 12x to the fourth y. So we're left with x minus y as well. Going from left to right, the 2 and the 12 are monomials, reducing to 1 over 6. The x squared on the top will cancel and we'll be left with an x squared on the bottom. So what I like to do is, as I'm doing this, I like to kind of write down what's left. The y cubed on top and the y to the 1 on the bottom will leave me with a y squared on top. And then the x minus y's cancel. So y squared over 6x squared is your final answer there. Okay, so I'll pause for any questions. And again, remember, it's just a matter of putting the negative exponents top and bottom. So again, if it's higher or larger on top, it stays on top. And if it's larger on the bottom, it goes in the bottom, the difference. Okay, so I'm just gonna let you guys start working on F. G is gonna be a little bit of a chunky problem, so we'll do G and H. Okay, so again, I'm just watching your time. Anyone that needs me, please feel free to unmute. I may want to just start doing lesson 8, like maybe the first slide or two. So if anyone, it's a little early, I think, we'll end early, but I'm not going to keep you till 10. But if anyone does want to, I think it would be a good idea to introduce, we'll see how it goes. Okay, so you're working on F. I'm just going to do something for my computer for a minute. You guys can continue to work on that. I just want to download adding and subtracting. Okay. After I print this, I'm going to start with you guys. Okay, so for F, there is no GCF in the numerator, but there is a difference of squares. So X plus and X minus 8. In your denominator, you have a trinomial, but your A value is 1. So 2 binomials, we're looking for factors of 72 that add to 17. That's X plus 9 and X plus 8. The X plus 8s are the same, but nothing else is. So we're left with X minus 8 over X minus 9. The next problem may prove to be a little bit of work, so I'm going to give you guys some time on that. And then, of course, H is the last one on that. So if you guys are done and you want to start, please feel free to do so. Yes,
Professor,
I'm all yours.
can you go over F again, please?
Can I go over F?
Yes, please.
Absolutely.
Thank you.
So I'll just do it from scratch, easier than trying to. This one, right, Sabrina? Okay.
Yes.
Okay, so again, the numerator doesn't have a GCF, but it is a difference of perfect squares. So you're going to get X plus 8 and X minus 8. Good so far?
Yes.
Okay. Denominator is a trinomial. There's no GCF. Excuse me, the A value is 1. So I'm looking for factors of 72 that add to 17. And that's X plus 8 and X plus 9. 9 times 8 is going to be 72. And 9 plus 8 would be 17. I'm then going to reduce the X plus 8s, and I'm left with X minus 8 over X minus 9, X plus 9.
Thank you.
You're very welcome. Okay, we'll start up G soon. What you should have realized with G, just so you can check yourself against me, is that you have a trinomial where A is more than 1. Okay, so you should be considering what to do there. So I'll start it up in a minute. Okay, so for number G, letter G, there is no GCF. It is a trinomial where A is more than 1, so we're going to have negative 70. We're looking for a pair of factors that will multiply to 70, but add to positive 3. So far, whoa, I don't know where 3 and 10 came from, 7 and 10. So 7 and 10 are our magical numbers. 4 does not go in evenly. 5 goes in, it was 5 times, I think, 14. Is that right? It is. Okay, that won't get me to 3. And again, you guys really shouldn't have to do all the pairs, but I get it. Because we want it to be a positive 3, we will use negative 10 and negative 7 and positive 10 to expand our middle term. So the 14x squared and the minus 5 go on the outside. I like the 7x with the 14x squared. I like the 10x with the minus 5. I'm going to factor out 7x and I'm left with 2x minus 1. Factor out 5, I'm left with 2x minus 1. So my factors are 7x plus 5 and 2x minus 1. And now I will put them back up in the top. So 2x minus 1, 7x plus 5. And then the denominator does not have a GCF, but it is a difference of squares. The 7x plus 5s are the same. So we're left with 2x minus 1 over 7x minus 5. Okay, so there was nothing really new in that, only you had a trinomial where A was more than 1. And so you had to consider how to deal with that value. Okay, so I'll give you guys some time on the last one. Again, if anyone needs me for anything, let me know. This is the first part of your homework, by the way, so you can certainly start that up, over the weekend if you want. Okay, I'll start up H in a moment. I would also suggest that you maybe get the notes for 8 out. I might just want to spend lesson 8. I just might want to spend a little bit of time on the first 2 slides just to get you guys going. So when we come in on Monday, what am I saying, on Monday, we can get it really going. So I'm going to just maybe do just a few examples, the first 2 slides, let's say. Okay, so I'll give you guys another moment. Okay, so again, we're going to check for GCF first. In the numerator, we have a GCF of 2x squared, leaving me with x squared minus 4x minus 21. That can continue to factor, but I'll start the denominator anyway. There's a GCF of 5x to the 4th, leaving me with x squared minus 9, so that can be factored. The trinomial has an A value that is 1, so factors of negative 21 that add to negative 4 is going to be negative 7 and positive 3. The denominator is going to have a difference of squares, giving me x minus 3 and x plus 3. Going in order from left to right, the 2 and the 5 will not reduce, but the x squared and the x to the 4th will reduce, so you're going to be left with an x squared in the denominator. And then the x plus 3s will reduce. So we have a 2 times x minus 7 on top. And then a 5x squared over x minus 3 in the bottom. The bigger you write or the more space you give yourself, the better it is that you don't miss something that you maybe wanted to include. So that is reducing in a nutshell. And the next lesson does have more of this. So I'll give you guys time. Of course, I will post this like I always do. But I do want to spend, like I said, a few minutes just quickly discussing our next piece, which will be the whole idea with multiplying. So I'm going to ask you guys to finish up whatever you need. If anyone still needs me, please let me know. Okay, I'm gonna ask you guys to take out lesson number 8. And again, I'm not gonna keep you much longer. I just want to ensure that we can at least get started right away on Monday. I keep thinking Wednesday because I don't even know what today is. Okay, so I'm gonna just minimize this. If you can find lesson 8, it should be up on the Blackboard site. Watch me not have it here. I should, yes. Okay, so I'm just gonna do these first 2 slides. And again, this is to just get you guys going so that, like I said, on Monday, we can really get into this further and we won't have any homework to go over. So you can, we can start this right away. So when it comes to multiplying polynomials, we're going to factor everything completely. And then we're going to cancel factors in numerators and denominators. And we're also going to be able to cancel across from each other. Now for A and B, these are special cases because these are monomials. So I'm going to give you guys a suggestion when you have monomials. Multiply everything first. You know what I'm going to write? I'm going to write multiply, or you know what? Let me change the wording a little bit for you guys. Let me do combine all exponents, sorry, before reducing. I'll show you what I mean. Okay, so for number 1, now we are allowed to reduce up and down. And if you're in this math class, you should know this rule already. We are also able to reduce top to bottom going across. So the 8 and the 18 and the 9 can reduce by a common factor of 9, leaving me with 2 and 1. Now, what I'm going to suggest you do to make your life easy is combine the 8 to the 3rd and the 8 to the 6th together as 8 to the 9th, and then b to the 8th on top, and then b to the 2nd on the bottom. By doing that, it makes it easier to finish simplifying. So we're going to be left with 2, 8 to the 9th, b to the 6th as our final answer. So again, you can reduce your coefficients as much as possible, and then combine your variables straight across and reduce after. So I'll open for questions, but why don't you guys try B without me? Let's see if you guys can do one without me. Okay, take your time with it. Okay, I'll give you guys a little bit more time. If you want to just at least check the coefficients, 14 and 16 have 2 in common, 7 on top, and 8 on the bottom. Now, that would leave me with a 7, and then the 3 times 8 would leave me with 24. If I could continue to reduce that, I would, but in this case, I cannot. Now for the variables, you have an 8 to the 2 and an 8 to the 8, which would give me 8 to the 10, and then b to the 6. In the bottom, you have an a and then a b to the 7th. So I like to do that and then reduce completely. 7, a to the 9 over 24b, because the 10 and the 1 will leave me with a 9 on top. The 6 minus 7 will leave me with a -1, so it goes in the bottom. So what you might want to do if you have time this weekend is, or before Monday's class, is why don't you guys try, maybe you try without me, and then that way when we come together on Monday, maybe you can see if you were on the right track. Okay, so we're going to do 2 more problems, but does anyone have any questions on A or B for me? Okay, for C and D, so I'll do C and then I'll let you guys try D. You are going to factor everything first because they are not monomials. So if they are not monomials, excuse me, you're going to factor everything first. Starting from the top left, I will factor out a GCF of 4, leaving me with x plus 3. The bottom left, I'm going to factor in an 8, leaving me with x minus 2. The more you factor, the easier this becomes. Top right, I'm going to factor out a 9. I'm left with x minus 2. And bottom, I'm going to factor out a 5, leaving me with x plus 3. Now, I'm going to start with my numbers first. So 4 and 8 happen to have 4 in common. 9 and 5 have nothing in common. So for the numbers or the coefficients, I will just have 9 over 10. Now, as you can see, I have an x plus 3 on the top and an x plus 3 on the bottom. As long as they are not directly across, they can be straight up and down or diagonal. You can cancel them. And then the same goes with the x minus 2's. So my final answer will be 9 over 10. Okay, so one more time, you guys can start at D if you'd like. You're going to factor everything completely on each fraction. Look at the numbers first, deal with those, and then cancel any like factors. Okay, so D is going to be a little bit more work, but I think you guys are up for the challenge. So why don't you guys try D? And then what I'll say is, I think we'll stop there. And on Monday, we will start with this and hopefully maybe even get ourselves a little more ahead. Okay, so please consider that. So I'll give you guys a little bit of time. It is 9:32. By 9:35, I'll start going over number 4, letter D. Okay, about 2 minutes. Okay, about last minute. So what I've done is I've labeled each type of factoring that you guys would use. So for the first numerator, you have a trinomial where a is 1. So you're looking for factors of 49 that give you 14. In the denominator, you have a trinomial where a is more than 1. So we step to the side and use the AC method. 2 times 21 is 42. So we're looking for a pair of factors that multiplies to 42, but adds to 17. That would be 3 and 14. So we will expand our middle term with 3x and 14x. I think the 14x drives nicely with the 2 and the 3x with the 21. I'm going to be left with 2x times x plus 7 and 3 times x plus 7. So I get x plus 7 times 2x plus 3. Okay, and I'll give you guys a moment to catch up and check your work or make any corrections. The numerator on the second fraction is not going to factor. The denominator will factor with a GCF of 2. And now we have no coefficients, so we'll start reducing. I like to go from left to right. So there's an x plus 7 on the top. and an x plus 7 on the bottom. There's an x plus 7, but no other one. There's a 2x plus 3, but no other one. And then there's a 4x minus 9 and a 9 minus 4x. That's the a minus b over b minus a scenario. So that will reduce to a -1. Again, it doesn't matter where you put the -1, but I always suggest in the top. So you have -1 times x plus 7 over 2. I forgot there was a 2 there. Sorry about that. Times 2x plus 3. And that would be your final answer. So the main idea here is that if you do not have a good grasp on factoring, you really, really need to get to that point. And it will take time, but it needs to happen. So my suggestion, as I said before, is try over the weekend to really identify what is giving you an issue and work on fixing that, whether it be the recognition, maybe it's your time, maybe you need to speed it up, whatever the case may be. So I'm going to stop here. I think that that is enough for one night. I will encourage you, however, if you want to continue to try these problems, by all means, go for it. We're going to finish these up on Monday, but it's not a bad idea if you want to at least work through the multiplication ones. So I'll say as an optional assignment, go for it. But we will certainly do that. So remember, your homework is not due till Wednesday. Your next exam will be 2 weeks from tonight. I will provide a review sometime next week and let you know the exact topics. So if you do not need me for any reason,